All right, for notes number 5, we're going to be multiplying and dividing radicals. I'm going to try to go through these quickly because there are a lot of examples and I want to make sure it's less than 10 minutes. So when you're multiplying radicals, there's several ways to do it. You could do the tree here, do the tree here. But I find it easier to just multiply them straight across. And so you get 10 and then you can always do the tree after. But this is just simple because 5 and 2 are prime. So you do not need to reduce this anymore. This is the most reduced it would be. Whereas something like this, actually, this is not an example of, okay. So for this one, the 5 and 2 on the inside is still 10. So that part doesn't change. So it's 5 times 2, right? So you get square root of 10. But this is the thing that's different is this outside number. So you would take the outside numbers and you would multiply them. So 7 times 8, and you would get 56. So this would be how it would work if you have a number outside of the radical. Okay, so for number 3, this is where you could do it 2 different ways. So you could do the tree here and then simplify it and multiply out. But again, I find it easier for me to multiply right away. So 3 times 2 is on the outside. And then on the inside would be 18 times 2. And that would be 6, and then the square root of 36. Now, 36 is a perfect square. That's 6 times 6. So we know that this part right here is equal to 6. So this answer is 6 times 6. And that 6 is from here, and then this 6 is from here. So the answer is 36. Okay, I know I'm going fast, but you can always go back and watch this as many times as you want. For number 4, again, you can choose if you want to reduce first or multiply everything at once. I just like to multiply everything at once. It's easier for me. So 4 times 6 on the outside, and then inside the radical is 50 times 4. So that would give me 24 and 200. Okay, so when we do the tree here, you can do 20 and 10. This is going to be 5 and 4, 2 and 2, 5 and 2. So I went all the way until I got prime numbers, 2, 2, 5, 5, and 2. So I've got a pair of 2s, I've got a pair of 5s, and then a leftover of a 2. So I'm going to bring out the 2 and the 5, but we already have the 24 there. So 24 times the pair for the 2 and the 5 for that pair. And on the inside would be the 2. So we just multiply that, and that's 24 times 10. So 240 square root 2. If you wanted to do it the other way, you could just do here like 2 times 2. Do 5 times 10, 5 times 2, and you'll see the same pattern comes out. You get the same things, and you can bring them out. So this would be 20 square root 2, and then this would be 12. Okay, so you could do it that way too. It's whatever way you want to do it. Okay, so for the next 2, those were all the multiplying ones that I'm going to go over. Yes, in class we'll talk about if there's a variable. But let's do dividing because that one's a little bit more complicated. Okay, so it's best when you have it, when you're dividing radicals, that you just put it all under one radical. So we're going to make one big radical, and the 24x squared is going to be on top, and the 3x is going to be on bottom. And that only works if they're both square roots and not like one's a square root, one's a cube root. So this is fine. And then we can simplify like the x's here. So there will be one leftover x on the top. And then we can simplify the 24 divided by 3 as well. So that reduces to 8x. And then you would do the tree again. So this would be 4 times 2, 2 times 2. So we have a pair of 2's, a leftover 2, and then a leftover x. So when you write your final answer here, that would be 2, and then on the inside would be 2x. Okay. All right, our last example for the video. I will do some harder ones and some more in class, but I'm trying to keep it a little straightforward on here. So when we're doing this one, we definitely want to multiply the radical by itself so that when you multiply the square root of 20 times the square root of 20, you would just get 20. That's what would come out, because the inverse of, so square root of 20 and then squaring that would just be 20. So they're inverses of each other. These cancel each other out. So that's essentially what we're trying to do so that we don't have a radical on the bottom. So we don't care about this 5 right now. Just leave it alone. We care about the radical because we don't want a radical on the bottom. You never do. It's kind of like you don't ever want 0 on the bottom. Same thing here. So we're going to actually multiply. So I'm going to change this to a multiply times the square root of 20. And we can't just do it on the bottom. Whatever we do on the bottom, we also have to do on the top. So we have to multiply square root of 20 on both. And that essentially doesn't change the problem because square root of 20 divided by square root of 20 is just 1. So when we do this, we're going to get on top 15 times 20 under the square root. And then on the bottom, we're going to get 5 and then times. Remember when I said these two multiplied is the same as this? We just get whatever numbers under the radical. So 5 times 20. And now we don't have a radical on the bottom. So here we have 15 times 20 still. And then here we've got, what is that, 100? Okay. And then we can simplify the 15 and 20. I'm going to leave it as 15 times 20 because that helps me. And then this is 5 times 3. This is 5 times 4, 2 times 2. So I can use this 15 times 20 to do my tree. So I'm going to have a pair of 5s, a pair of 2s, and a leftover 3. So that's going to give me on outside 5 times 2 square root leftover is 3, and that's over 100. So 5 times 2 is 10. And if we have 10 square root 3 over 100, this reduces because 10 goes into 100. So this would be the square root of 3 over 10. All right. Go over those again if you need to. Write down your notes, and we'll do some more complicated ones in class.